Hello children, welcome to another session of PYQ JEE Advanced. Here I am with a question from salt analysis. This year we know they have given extra emphasis on salt analysis or analytical chemistry. So a very simple question what we do in our lab, directly a question from there which had appeared in one of the previous JEE Advanced paper. So here the question is single option correct question. An aqueous solution of a mixture of two inorganic salts. There are two inorganic salts. So there are two cations and maybe there are two anions. When treated with dilute HCl, gave a precipitate P. So when treated with dilute HCl is for group 1 cations. Dilute HCl is the group reagent for group 1 cation, where the chlorides of these metal ions have very low KSP, or chlorides of these metal ions will be precipitate. So all those metal ions whose chlorides are sparingly soluble or having very low solubility, or those which will get precipitated, are tested by the group reagent dilute HCl. So it gave a precipitate as well as a filtrate, meaning amongst these two inorganic salts, one cation must be a group 1 cation and the other cation must be present in the filtrate. So P has a group 1 cation in it. As we know, the group 1 cations are silver Ag plus because AgCl is sparingly soluble, Pb2 plus, PbCl2 is sparingly soluble, so Pb2 plus, or mercurous ion Hg2 plus because mercurous chloride is sparingly soluble. All the other, it can be an Ag plus salt, it can be a Pb2 plus salt, it can be a mercurous salt, or any of these whose chlorides are water insoluble. Now the clue, the precipitate P was found to dissolve in hot water. Now it's very clear that it is lead chloride which dissolves in hot water. AgCl will not dissolve in hot water. AgCl in fact dissolves in ammoniacal solution, ammoniacal silver nitrate solution. It dissolves in ammoniacal solution. AgCl dissolves in ammonia to produce soluble ammoniacal Ag plus complex. It is soluble in ammonium hydroxide solution, Ag plus. It is lead chloride which is soluble in hot water. So we got an idea. P must be containing Pb2 plus ions and the reaction is Pb2 plus with the chloride ions from HCl form PbCl2 which is sparingly soluble, which dissolves in hot water. So P must be containing Pb2 plus ions. Coming to filtrate Q remained unchanged when treated with H2S in dilute mineral acid medium. So this is the group reagent for second group cation, that is dilute HCl followed by H2S. First dilute HCl and then H2S. Group 2 cations are those cations whose sulfides have got very low KSP, where the sulfides get precipitated even at low concentration of sulfide ions in solution. So in presence of dilute HCl, a common ion dilute HCl will suppress the ionization of H2S and only very less sulfide ions will be produced, which is enough to precipitate just group 2 cations if present. Cu2 plus is a well-known example where copper sulfide immediately gets precipitated as a group 2 cation. Whereas when you go to this particular compound from that inorganic salt, this particular cation is not being precipitated when this group 2 reagent is added. Very clear that it is not a group 2 cation. Coming to the next explanation, it gave a precipitate R with H2S in ammoniacal medium. In acid medium, it is not precipitated with H2S, but in alkaline medium, in basic medium, that is, it is precipitated as H2S in an ammoniacal medium is given. The precipitate R gave a colored solution S when treated with H2O2 in an aqueous NaOH medium. So it's very clear that with H2S in ammoniacal medium, it is giving a precipitate, and whoever be the cation present in the precipitate, that is oxidized by H2O2 in alkaline medium. An oxidizable species must be present there, and which forms a colorful solution. So definitely when you go to the option, it cannot be ferric, because ferric is not oxidized by H2O2 in alkaline medium. And zinc sulfate, zinc is not going to give a colorful solution, Zn2+. So when you go to chromium, there is a possibility for chromium, where chromium 3+ ions, if present in solution, when you treat it with ammonium hydroxide H2S medium, chromium hydroxide is precipitated. Remember, it's not chromium sulfide, it's chromium hydroxide has got a lower KSP value or lower solubility than chromium sulfide. So it is chromium hydroxide which is precipitated, CrOH thrice, which is a green precipitate of chromium. This is the precipitate R. Now this, when treated with H2O2 in alkaline medium, Cr3+ is oxidized by hydrogen peroxide in alkaline medium to chromium +6, and in alkaline medium it exists as chromate. So the compound must be Na2CrO4, which dissolves, which is water soluble, which is a yellow colored solution. So P must be a lead salt and Q must be a Cr3+ salt. So the options given, out of the options given, the last one, dog option, Pb2+ and Na2CrO4 must be the correct answer. So to begin with, PbCl2, water insoluble, which dissolves in hot water, which gave us the conclusion that Pb2+ must be a cation in one of the inorganic salts. The next clue says it must be a species, a cation, which is precipitated with ammoniacal H2S, which is oxidizable by H2O2 in alkaline medium. So that must be, and that product is a colorful product, it is said. So that must be, from the given options, it must be chromium 3+, which is present, which with ammoniacal H2S, ammonium hydroxides, with hydroxide it gets precipitated due to the low solubility of CrOH thrice, and you get green precipitate of CrOH thrice, which with H2O2 in NaOH gets oxidized to Na2CrO4. From +3 state, chromium is oxidized to +6 state, and in alkaline medium it exists as chromate, and which is yellow in color. So option D is correct. Thank you, children.